push that rock here with Simpson math. Let's integrate cosecant cubed. So to integrate cosecant cubed, I'm going to do an odd man out. I'm going to kick out an odd man. So I'm going to say it's cosecant squared x times cosecant x dx. Then I'm going to use parts. I'm going to say, let's let f be cosecant x, because the derivative of f then would be, let's see, the derivative of cosecant is negative cosecant cotangent. Then I'm going to let g prime be cosecant squared, because see, we can anti-differentiate cosecant squared, because we know if we differentiate cotan, we get negative cosecant squared. So if we anti-differentiate cosecant squared, we get negative cotangent x. Now, the parts formula says you take f times g, so I have a negative cosecant x cotangent x. So this times this goes here, minus the integration of f prime times g. So the formula is f times g minus the integration of f prime times g. Now I have a negative times a negative, so that's a positive. And it's cosecant x cotangent x times cotangent x, so that's going to be cotangent squared x with respect to x. We're going to integrate it. Now we got to remember that over here we are integrating, what are we integrating again? It's cosecant cubed x dx. This is going to be important. Remember, with parts, frequently you need to remember what's over here, because if it shows up over here, you add it over. I think we called that the merry-go-round. Okay. Now what I'm going to do next is I'm going to look at this cotangent squared, and I'm going to use the Pythagorean identity. So one of our identities is 1 plus cotangent squared x equals cosecant squared x. So that means that cotangent squared x is equal to the cosecant squared x minus 1. So I'm going to use that so that I do get the cosecant cubed that I'm needing. So I'm going to rewrite this as cosecant x. Then cotangent squared is cosecant squared x minus 1 dx. And I see that when I distribute, I'm going to have a cosecant cubed x. That's nice. I can add that over, see? And then cosecant times negative 1 is cosecant x dx. And I'm kind of forgetting this for a minute, but it's out there. We still have this negative cosecant x cotangent x. It's not trouble because it doesn't have an integration symbol in front of it. It's fine. This is the trouble. Now I'm going to distribute this negative and this integral sign. Remember, you can bust up plus and minus. You can integrate term by term because it's a linear operator. So that means I can say this is minus the integration of cosecant cubed x with respect to x, but it's plus the integration of cosecant x with respect to x. And over here I have cosecant cubed x dx. So what I'm going to do on my next page is add this to this so I have two of them, okay? And I'll still have this tricky integration to do. Okay. So, I had this note here to remind me. Okay, and then I had this note to remind us that the derivative of cosecant is negative cosecant cotan. That means the antiderivative of cosecant cotan would be cosecant, so the negative. I had all this here and I forgot to remind me that if you're doing cosecant squared, you get cotan because, of course, negative cotan, because of the derivative of negative cotan, you kick the negative out. The derivative of cotan is a negative cosecant squared, but that negative makes it positive. So all of this was here, and I forgot to remind us why when we integrated cosecant squared, we got negative cotan x, and when we took the derivative of this, why we got negative cosecant cotan x. So I kind of just acted like we knew all that, but when I planned the video, I had said maybe I should remind y'all. Okay, but where are we? Where we have 2 of the integrations of cosecant cubed x dx, and it's equal to, if we'll remember, it's equal to the negative cosecant cotan minus the integration of cosecant x dx. Now the way we're going to handle that, no, it was plus. Okay, plus, okay, because the negative distributed. Now the way we're going to handle this, we're going to go bananas. That's what we're going to do. We're going to go bananas. I'm going to scoot this over. I wrote it too. I'm crowded. Negative cosecant x cotan x plus this. And then we're going to go bananas. What does that mean, dude? That means multiply by a form of 1 that is just plain bananas. And this time though, it's going to be plantains. Plantains, not bananas. So what are we going to use? Let's think about that. There's a lot of choices here. With secant, our banana is secant plus tangent. So we could do something like that. We could probably be clever with the negative sign, but I'm not going to worry about it. You know, negatives always work out. So I'm just going to put cosecant x plus cotangent x here. And I have to multiply by a form of 1, so I'm going to put the same thing in the bottom. But now this distributes to the numerator. So I have in my numerator cosecant squared x plus cosecant x times cotangent x. And the cool thing is that this up here is exactly the derivative of this down here, right? I'm going to turn it around. I'm going to put the cotan first plus the cosecant next. Right? The derivative of cotan is cosecant squared. Yeah, it has a negative, and the derivative of cosecant is cosecant cotan, and it also has a negative. So I need negatives up here. Well, that's easy. Here's what we'll do. We'll change this out here to a negative, okay? We're going to make this a negative right here. Okay, now that means I can put a -1 right here, but I'll distribute the -1. So this will be negative, and this will be negative. So see, this negative distributes in and makes that positive, which would be positive cosecant squared, and makes that positive, which would make that cosecant times cotan positive. So we're all good. So by putting this negative out here, I get what I need. Now if I let u equal the denominator, then du is, the derivative of cotan is negative cosecant squared x. And the derivative of cosecant is negative cosecant x cotangent x. And then you multiply that by dx. So notice du is exactly my numerator. How convenient. So I get 1 du as my numerator. This is just 1 du. So 1 du is all that numerator, and u is the denominator. How about that? And don't forget we have all this other stuff over there. But when you integrate 1 over u, you get the natural log of the absolute value of u, okay? And what was u? Well, it was cotan plus cosec. So I get minus the natural log of the absolute value of cotan x plus cosecant x. Don't forget this. It was negative cosecant x cotangent x. Don't forget your plus c. And then remember, we had 2 of them. So how do I get rid of that 2? You know, there's a 2 here. So there's a 2 here. Well, you would just divide everything by 2. You know, you can divide the c by 2, but it'd still be a c. So I'm just going to divide this, all of this by 2. I mean, the c is just some constant. So there's the antiderivative of cosecant cubed. Math made simple. Simpson Math.